Hello everyone, welcome to our lecture number 2, that is the chapter units and measurement of class 11. So in lecture number 1 we have discussed up to system of units, that is CGS, MKS and FPS system. Next we will discuss SI system. It is called your international system of units. International system of units. And listen one thing here, in general conference of weight and measure, in general conference of weight and measure, which was established in 1971, in that conference a new system was developed. A new system was developed. Yes, and this system is called, that is SI system. And as per that conference, it has been decided that there are SI system contains 7 fundamental base units and 2 supplementary units. So what are they? First is we have to write base quantity. Base means fundamental. Base quantity. Next one is base quantity SI unit or what fundamental quantity units. So base SI units. Next, unit symbol. Unit symbol. Okay, so we all know there are 7 fundamental quantities are there. That is your length, then mass, then time, then temperature. Next one is electric current. Next, luminous intensity. And last one is amount of substance, or we have discussed it is quantity of matter. Amount of substance or quantity of matter. Yes. And the SI units are length SI unit is meter, then mass SI unit is kilogram, salt is denoted by kg, here it is small m, then time SI unit is second denoted by s, then temperature SI unit is Kelvin denoted by capital K. Next, electric current SI unit is ampere. How to write the SI unit? What are the rules? We will discuss in today's class. Okay. So electric current SI unit is ampere denoted by capital A. Luminous intensity it is candela and denoted by CD. Then amount of substance is mole. Symbol is MOL. In addition to this, there are 2 supplementary units. So 2 supplementary quantities are plane angle, another one is solid angle. Yes, and plane angle SI unit is radian. Regarding radian and steradian also we will discuss today. So solid angle SI unit is steradian, that is steradian. And here radian symbol is rad, R-A-D. Steradian is SR. I hope it is clear to all of you. Okay. So let's come to the meaning of plane angle and solid angle in some detailed manner. Yes. Okay. So next we will discuss about your plane angle. Remember, the plane angle concept is applicable for circle, and circle is 2-dimensional figure. That means whatever we will discuss in plane angle, that is applicable for 2-dimensional figure. So one is your plane angle. Yes, that is for in 2D. Okay. This is a circle, and we can say this is the center of circle O. Yes. Let us consider a very small arc. Let us consider a small arc. And the length of the whole arc is S. The length of the total arc, that is your biggest arc, is 2 pi r. Its length is 2 pi r. So its length will be 2 pi r, Out of the whole, the red color portion arc is a very small length. Let it be dl. What is dl? dl means differential part of the L. Your L is the total arc length. And dl means differential part, and that means out of the whole we are considering a small portion. So this dl portion of arc makes an angle. Suppose that angle is d theta. D theta means the whole total biggest angle is theta, and out of the whole angle it is a very small angle. Let us consider d theta. D means differential portion of theta. So remember, if this is your rod, its length is suppose L. Yes, if out of the total length, if we will consider a small length out of the whole, then it will be dl. Like this, you have to think about dl, d theta. And what is the radius? Is r. Radius is r. So as per the formula, we all know angle is equals to arc by radius. Arc by radius. So we can write angle is d theta, arc is dl, radius is r. And what is the value of, what is the unit of d theta? Plane angle, that is your radian, rad rad. So d theta is equals to dl by r radian. Or you may write ds by r. Let us consider it as ds. Okay. ds by r. D theta equal to ds by r. Arc length is ds. So plane angle is the ratio of length of arc to radius r. So we can write thus plane angle is the ratio of arc length to radius. Okay. Yes. And unit of radian, that is unit of solid plane angle is radian. Yes. Okay. So who can say, now think about the maximum value of d theta. D theta maximum is what? What can you say? What is the maximum value of d theta? Yes. So when for d theta to be maximum, remember, for d theta to be maximum, ds should be maximum, because d theta depends upon ds. And what is the maximum value of ds? ds means length of the arc. So maximum value of the length of the arc is 2 pi r, that is equal to 2 pi r. Yes, so we can write from the formula d theta maximum is equals to 2 pi r divided by capital R. 2 pi is capital R, here radius is capital R. So 2 pi capital R by capital R. This much radian. This is equals to, after solving we can say 2 pi radian. So maximum value of plane angle is 2 pi radian. This is one short question. Maximum value of plane angle is 2 pi radian. This is the answer. So 2 pi capital R by capital R radian. That is 2 pi radian. Again, another question is there. Define 1 radian. Define 1 radian. Define this concept. So remember, d theta is equals to, we know d theta is equals to ds by r radian. And also you apply one condition, when ds is equal to r, then what will be the value of d theta? D theta will be equal to ds by ds, because r is equal to ds. So ds by ds radian, that is equal to 1 radian. So simply you came to know that how to write or how to define the meaning of 1 radian. Yes, whatever I have written in the box mathematically, you have to write in language. That will be the definition of 1 radian. Okay, so what you have to write? We can write, when length of the arc is equals to radius of the circle, then angle subtended by the arc with respect to center of the circle is called 1 radian. So in language, same thing we have to write. You have to write, when length of the arc, is equal to radius of circle, then angle subtended by arc with respect to center of circle is called 1 radian. So this is all about your radian concept or plane angle concept. And you remember, plane angle is applicable for two-dimensional figure, that is circle. Yes. Next come to our solid angle concept. Solid angle. So remember, what is the value of d theta maximum? 2 pi radian. Also from this we came to know 2 pi radian means what? 2 pi radian means 360 degree, because maximum value of angle, the whole arc makes an angle 360 degree with respect to center. So in note point you may mention in note point 360 degree is equals to 2 pi radian. So like this, dividing 2 on both sides, that will be 180 degree is equals to pi radian. 180 degree is equals to pi radian. Again divide 2 on both sides, 90 degree is equals to pi by 2 radian. Again divide 2, 45 degree is equals to pi by 4 radian. Like this we can write. So 360 degree is equals to, or 180 degree is equals to pi radian. That means we can write 1 degree is equals to pi by 180 radian. Pi by 180 radian. You may write like this. Yes, another relation is there. What is that? Important relation, degree, minute and second relation. So 1 degree is equals to, remember, 60 minutes. That is equals to, we can write 60 minutes like this. Okay, and remember 1 minute is equals to 60 seconds. Okay, in notation you have to write 60 seconds like this. Yes, and 1 degree is equals to 60 minutes is equals to 3600 seconds. Okay, these are some useful conversions. So next is our concept of solid angle. Concept of solid angle. Okay, now see this thing. Concept of your solid angle. Yes, it is applicable for 3D case, 3-dimensional figure. Let us consider this is your sphere. This is your sphere of radius r. This is the center of the sphere, and as it is sphere, I am going to set like this. Okay, because it is 3-dimensional figure, we can't draw it in 2D space. This is 2-dimensional plane. The surface of this device plane, that is 2-dimensional. This is suppose that sphere. Yes, the whole surface area, let it be A. So out of whole surface area, let us consider a small area. This small area value will be dA. This value is dA. And what is the angle made by this small area with respect to center? The angle is your solid angle. And let this angle is d omega. Yes, solid angle denoted by symbol omega. So just think about your cone ice cream. Okay, so in case of cone ice cream, it looks like this. Yes, this is that small area, consider that. Yes, and this is the angle made by this small area dA. Angle made by the small area dA with respect to center of the sphere. Let this angle is d omega. This is your solid angle. So what is the relation? Relation is d omega, and radius of sphere is capital R. So you can remember d omega, the formula is dA by capital R square steradian. Unit is steradian. D omega is equals to dA by R square steradian. This is the answer. Yes. So now we have to find what is the maximum value of d omega. Yes. So find d omega maximum value. So same answer as the previous answer is, for d omega to be maximum, dA tends to maximum. And what is dA? dA is the area, small area on the surface. So maximum area means that is the total surface area of sphere. Radius is r, so surface area of sphere is 4 pi capital R square. Yes, now we can say the value of d omega maximum is 4 pi r square, that is your, instead of dA max we can write 4 pi r square divided by r square steradian. It is equals to 4 pi steradian. So d omega maximum is 4 pi steradian. This is your answer. Maximum value of solid angle is 4 pi steradian. Yes. And one more question is, define 1 steradian. Define 1 steradian. How to write this answer? We know the formula is d omega is equals to dA by r square steradian. And in this case you use one condition, when dA is equals to r square, then find the value of d omega. D omega is equals to 1 by 1, that is 1 steradian. Finished. So sentence like this, like the previous one, define 1 radian, you have to define again 1 steradian. Okay, whatever is written in this white color box, we have to convert it into language. So what do you have to write? In this case, what you have to write? Now listen to the sentence properly. After that, I will write. When the cutout area of a sphere, dA means cutout area out of the hole. When the cutout area of a sphere is equal to square of radius of the sphere, then angle made by this cutout area with respect to center of the sphere is called 1 steradian. So in language, what you have to write? When cutout area of a sphere is equals to square of radius of sphere, then angle made by cutout area with respect to center of sphere is called 1 steradian. This is the definition part. And maximum value of omega for a sphere is 4 pi steradian. D omega maximum is called omega. Yes, I hope it is clear to all of you. Yes. So this is about your plane angle and solid angle. Yes, one more thing is there. For entrance point of view, you remember one relation. No need to derive it. Okay. You remember one relation. What is that? The relation between plane angle and solid angle. Yes. Now see this thing. Relation between plane angle and solid angle. Plane angle we can denote it as theta, solid angle omega. Yes. Okay. So let's think this figure. Think about this figure. Yes. And we can say this angle is your omega, suppose, and this angle is theta. This is one of the plane angle, na? This line and this line. Plane angle is theta. The relation is omega is equals to 2 pi into 1 minus cos theta. So in class 12, the first chapter is electric charge and field. During the time of flux calculation, electric flux calculation, this formula will help you a lot. Yes, this is the relation between plane angle and solid angle. So keep it in mind. This is about your plane angle and solid angle. Next we will discuss what? We will discuss the rules or guidelines for writing SI units symbol. These are very simple concept. Okay, very fundamental. So guidelines for writing SI units in symbols. Yes, very simple guidelines are there. So listen it properly. First is standard units or SI unit symbols are written in lowercase Roman type. SI unit symbol is written in lowercase Roman type. That means, for example, after the example you can understand easily. Kilogram. Kilogram is the SI unit of mass. Kilogram. Kilogram, its symbol is small case small g. So this is your lowercase Roman type. Small case small g is lowercase Roman type. I hope it is clear. Then come to the second point. Second guidelines. Unit names are never capitalized. So unit names are never capitalized. Yes, okay. However, unit symbol is capitalized. However, unit symbol is capitalized. Condition only if the unit is named after scientist. Only if the unit, in first point we have written or we have read unit symbol always written in lowercase Roman type, but in this point unit symbol is capitalized. Condition if the unit is named after scientist. If the unit is named after scientist. Yes, okay. For example, now see, suppose unit of force, SI unit of force. What is that? Answer is Newton. So if you write Newton like this, it is wrong. Yes, capital N से शुरू करोगे तो it represents the name of that person. But for symbol you have to write NEWTON like this. Okay, and in symbol you can mention capital N, that is correct. But if you write small n, this is wrong. So unit symbol is capitalized. Unit symbol is capitalized. See this point. If the unit is named after scientist, it is capitalized as it is named after scientist. Okay, I hope this second guideline point is clear. Then come to third. Third point is, if a unit named after a scientist, this is one of the interesting point. If unit named after a scientist contains two letters in its symbol, then initial letter of symbol is capital. Then initial letter of symbol is capital. Okay, for example, unit of frequency, that is Hertz. The answer is HERTZ. You have to start from small letter. In symbol you have to write capital H, small z. First letter of symbol is capital, then second one is lowercase Roman type, that is small. Yes, okay. Then fourth number point. Number 4 is unit symbols are never used in plural form. Or in next point you write symbols are not followed by a full stop. Symbols are not followed by full stop. This is very easy point actually. Next guideline rule is point number 5. In point number 5, all of you mention unit symbols are never used in plural form. Yes, for example, 100 meters. 100 meters, if you write like this, it is wrong. 100 meter. No need to write in plural. Then it is wrong. If you write in plural form, it is wrong. Then point number 6. Not more than one solidus. Not more than one solidus should be used. Should be used. What is this? Now see. This one should be used in a unit symbol. In a unit symbol. What is this? If you write meter per second square, another student is writing like meter per second divided by second. So remember, not more than one solidus. Here one solidus is there, so this is correct. Here two solidus are there, so this is wrong. So not more than one solidus should be used. Clear? So these are some guidelines to write the what? SI units symbols of SI unit. Then we have to remember some multiples and sub multiple. Yes, some multiples and sub multiples. Okay, now see this is one of the interesting part actually. For numerical solution we have to use this thing. So for multiples, some multiples, now see, first is deca, next one is hecto, then kilo, then mega, next one is giga, next is tera, next is peta, not petal, this is peta. Okay, yes, and the symbol of deca is da, hecto, that is small h, kilo, small k, mega, capital M, giga, capital G, tera, capital T, capital P, and its value is, deca value is 10 to the power 1, hecto means 10 to the power 2, kilo 10 to the power 3, mega 10 to the power 6, giga 10 to the power 9, tera 10 to the power 12, peta 10 to the power 15. Up to this you can remember. Then come to some sub multiples. Then let's discuss some sub multiples. Sub multiples, what are they? First we have to write factors. Here deca, hecto, kilo, all these are factors. Then this is the prefix. Prefix, that means which is fixed before, then its symbol or its value or symbol was like this. Factors are, in case of sub multiples, deci, then centi, then milli, then micro, next one is nano, next one is pico, last one is femto. So many are there. What do you remember? This much. So then next is your prefix value. Prefix means that you can write, sorry, I have written in a digital format, deca, hecto, kilo, mega, these are what? These are your prefix. Yes, these are the prefix. Then these are the symbol, and these are the factors, 10 to the power 1, 10 to the power 2, all these are factors. Here deci, it is prefix, it is under prefix. Then you have to write its symbol, you have to write their symbol. Next one is factors. Deci means symbol is D, centi, that is C, then milli, small m, all these are small letter, micro, mu, nano, small n, then pico, small p, femto, small f. Okay, then its factors, deci 10 to the power minus 1, 10 to the power centi means minus 2, milli 10 to the power minus 3. Next one is micro means 10 to the power minus 6, nano 10 to the power minus 9, then pico 10 to the power minus 12. Yes, femto means 10 to the power minus 15. So keep all these things in mind. All of you note it down and keep all these things in mind properly, so that it will help you in your upcoming numericals. I hope it is clear. Okay, very good. Let's solve one question. Okay, one fundamental question. Okay, it is not very difficult. I know you all have completed this chapter, but still you try your best to revise it. Yes. Okay, question is density of an object. Density of an object is 10 gram per cc. So what is the value in SI unit? What is its value in SI units? What is its value in SI units? Find it. Remember, density it is given. Density is equals to 10 gram per cc. Cc means cubic centimeter. So 10 gram per centimeter cube. Yes. So how to solve this? Now see. So 10 into 1 gram means we have to convert it into kg. 1 kg 10 to the power 3 gram. So 1 gram 10 to the power minus 3 kg. Yes. Divided by bracket, then cube, and inside the bracket centimeter is written. And what is the value of this thing? C value means centi. Centi means 10 to the power minus 2 and meter. Then it will be in numerator it will be 10 to the power minus 2 kg divided by 10 to the power minus 6 meter cube. So after solving you will get 10 to the power minus 2 plus 6, that is 10 to the power 4 kg per meter cube. Yes. So this is the answer of this density value in SI units. Okay. I hope it is clear to all of you. So this is all about for lecture number 2. I hope it is clear to all of you. All these concepts are very simple, available in this lecture number 1 and lecture number 2. So kindly like, share and subscribe this channel. And in lecture number 3, we will discuss directly regarding the dimension part. Okay. So stay tuned for next update. Tomorrow I will upload your next part, that is dimension of physical quantity. Okay. Thank you.